Welcome to episode 31, Streamline Conference 2026, C-Suite Reliability and Measurable ROI, Energy and Emissions Strategy, DOE Verify and Measure, EPA Emissions Tools, turning maintenance insight into executive value.
Hello, and welcome to the Valentine's Day edition of the Chaos and Caffeine podcast. This will be episode 31. We're covering today a couple of things. One is, of course, a coffee, which we will cover in a second. Then, of course, we're going to kind of do a very, very quick commentary on the Streamline conference that we attended last week. Might even go into, because I drove there. I'll leave out all the traffic nonsense. But in any case, and then finally, we're going to get into a topic that came up there, and a book I picked up last week, and then some tools for the financial side of the reliability and maintenance. And basically, how do we communicate success and how do we do certain things in order to show that success, and how do we start in chunk sizes and work our way up. So let's start with our coffee, which I stayed at a Marriott, kind of apartment house thingy when I was there, and so I had to pick up groceries for my evening meals. So I stopped by Trader Joe's, and I figured I would try some of their coffee. This is a Colombian coffee, and it is described as Colombia produces some of the best coffee in the world. Due to the mild and well-balanced beans grown there, we've harnessed this exquisite Colombian coffee in a convenient single-serve, organic, fair trade, direction. It has directions. Follow manufacturer's instructions to warm up brewer, select brew strength. Wow, I've got a Keurig. It only does one brew strength. But what I thought is interesting, I opened it up, and it's in plastic, and they go for that, minimal thing, so it's not all plastic that basically would be garbage if you're into that. And by the way, it makes it, when I open this up, it makes it very, very aromatic. I mean, but it smells good. It really does. So I'm considering taking one of those pods and just laying it on the desk so I can smell coffee all day. In any case, let's go ahead. Got the Chaos and Caffeine cup. Let's give it a try. I actually really have not tried this before. I have a second cup because it smelled good. It smells just like it after it's been brewed. Not bitter at all. More or less pretty smooth. A little bit of bite on either side of the tongue like I like. And remember, I drink it black. Be perfectly honest, if people are into putting horrible stuff in, like milk or whatever, almond milk or whatever else into their coffee, this would be well suited for it. Not too bad. Congrats for what turned out to be a really inexpensive coffee. I think it was $9 for 12 cups, or 12 packs, which means it'll last me today and tomorrow. Or actually, probably just today. So anyways, first we'll cover the Streamline conference, and then I will talk quickly about this book, and then we're going to take a look, because the book does a lot of links to a website. There's a lot of in-book sales. For those who are into gaming, I have in-game purchases. This has in-book purchases. So you can get it as an ebook too. Probably recommend that. But and I'll explain why when we get into it. So the Streamline conference was actually one of the best of the non-trade, professional society meetings I've been to in a while. Long list of names were there. As a matter of fact, a lot of us have not been in the same room in a decade in a few cases. So it was quite interesting. We had a lot of like-minded folks where we weren't there to sell stuff. We were there to educate because, there's always a commercial aspect to everything. But I was long ago taught educate, don't sell. In that circumstance, there's a time for sales and marketing, and there's a time for getting up and educating the customer in your new ideas, capabilities, things like that. You don't have to go down and turn it into a timeshare sales bullshit, right? So the team there was outstanding. In any case, the team consisted or was led by Alex Bolan. Great conference. He promised it would be non-commercial, enticed me into going there, along with Greg Christensen of CMMSRadio. Sorry, I've paused a few times so far because I'm tripping over my own tongue today. I just got back 2 days ago from this, and I drove there. It's Chicago to Greenville, South Carolina, is about 12 hours. I will say I've complained about some of the electronics in this truck before, and some of the things that are going, kind of awkward in it. But I will say that it literally saved my life a couple of times. Other drivers, like a truck in the right-hand side, and I'm driving along, and I'm halfway along it, and it just switches lanes. I was looking for the video because the other thing is these new vehicles have 360-degree continuous streaming video into a card inside the vehicle. So I should have pulled it out right then to grab it, but tried searching for it a little later, because after that occurred and I went off the road to avoid him. I got back on. He just carried on as if nothing happened. I found out why when I got up to him. He had a big phone, like one of these that cover the whole side of your face, on the left-hand side. So he wasn't even looking at his mirror out the side. And I caught that one as well. So I'm going to be looking for that video footage later. But that wasn't the only instance like that I had. It's getting quite treacherous on the roads, we'll put it that way. And I'm not a shy driver. I'm a very cautious driver. I pay attention. I do not talk on the phone. I don't answer email, and I don't do texts. I have all that built into the vehicle. I did try the AI version, and I'm going way off topic here, but I did do the AI version, and then had to shut it off because I saw some of the answers it was sending back, and they did not resemble reality. And then another time I allowed it to summarize through AI texts and emails I was receiving, and the information I was getting didn't resemble reality at all. So, the usual AI stuff. It would be great if it worked. Actually, it's kind of funny because the previous versions worked that were not considered AI, but neither here nor there. So, getting back to the conference. I got to sit in one room and went through a track that was quite interesting. We had a couple of good keynotes, including Bob Latino, of course, who kicked the whole thing off. And it was perfect because we were all able to tie our presentations back into it. George Williams, of course, with ReliabilityX. Greg Christensen was doing interviews the whole time. I didn't, unfortunately, get a chance to do that because I was actually sitting back just really enjoying all the presentations for the first time in a while. I mean, you see me at some conferences, I'm hanging around on the show floor because really I've seen the sales presentations over and over and over again at a lot of these places. So Greg Christensen and CMMSRadio did a great job there. Andy Gager, great presentation. Trent McJunkin, of course, always phenomenal. Our tried and true, end user. Basically, he's a practitioner who is allowed to go to these, and he he's got a tremendous amount of experience and has actually been doing what everybody's been talking about. So I get to give him that moniker too. So anyways, Shon Isenhour was there. I didn't get to see his workshop on the last day, but we did chat a lot. Great guy, doing a lot for the industry. Joel Levitt, that was just fantastic. As a matter of fact, when I get into one of the ways of going in and starting out your program and getting people engaged and being able to show what you do, that is something the DOE did, but his whole presentation was about that. Just do small bite projects, cleaning up benches or taking on a sore spot, things like that. Phenomenal stuff. Great comic books. Jeff Shiver, of course, finally got to sit through one of his planning presentations. Haven't in a very, very, very long time. And it was great because a question had come up. Well, what about, your methodology versus this person and this person? And, it comes down to the concepts they have are similar. Some are, the approaches are a little different. But the point is, like the thought of overscheduling a day, which falls under somebody else, and so on. 100% of the day, and so on and so on. It depends on what your KPI are, really. And then, of course, I refer to them as the newer generation because they're starting to show up at a lot of these conferences. I've been talking to them now. New generation, means that we've been chatting for several years now. And been doing a lot together, primarily since 2020. So I kind of look at a dividing line, pre-2020 and post-2020. So, yeah, I think we're in 6 AC or after COVID. But Brian Bieschke and Matt Knuth, phenomenal guys, really into everything. Bryan, of course, another Navy carrier sailor. We've been talking a fair amount on a lot of things, including our experiences. Now, it was funny because some of us let out a few oopses in our talk. Different language that you might not consider overly polite, but Bryan and I were good at that, I guess. Sorry, but it happens. And we started this thing when one of us would do that, the other one would go GoNavy. But I think we had a whole group doing it. But in any case, great stuff. I mean, really, I'm going to take my presentation. I think Jeff referred back to it about a technical presentation, and I had to let him know afterwards, no, this was actually a presentation I hadn't really done in about 20 years, back when I was doing the C-level consulting stuff, and just found that playing with the tools on, closer to the floor while also interacting with C-suite is a little more fun for me. So, inventing things, coming up with solutions to make it easier for the end user, that's my thing. Solving problems, right? I can do really well at the other stuff, and I did. I won awards over it. But what I did is I talked about how to, select CBM and proper frequencies and so on and so on. And we're going to, I'm going to take the presentation I did because I was updating a presentation I think I did last in 2008 and clean it up a little bit. I had added AI related technologies and so on. A lot of stuff. It was very technology agnostic. It was how to select it and best approaches so that you have evidence-based reasons for doing it. And I'm going to end up probably next couple of weeks do a live recording. It might have to be on a weekend. We'll see. Depends on travel. A lot of travel. I went from slow year last year with right around 40 weeks on the road. It's looking like it's going to be back in that 46 range again. So in any case, yeah, those I may be leaving a few folks out. I know I'm leaving out a lot of the attendees. It was phenomenal. Not a huge crowd, just large enough, and of the people that wanted to interact. It was primarily an EAM conference, but I would say I had somewhere between 30 and 40 people in my presentation. Um, uh, there were several that had more because it tied more to EAM. And then it also depended on what the two other tracks were, which were primarily EAM and CMMS related. So in any case, phenomenal conference. Would I do it again? Absolutely. If they keep that direction, fantastic. Most of our industry could probably learn from what they did. Let's put it this way. When I go to a lot of the conferences and I see the marketing guys get up speaking, I'm not thinking of them as the legends of the industry. I was with the legends of the industry. So with that, yeah, fantastic. Now, let's roll into the next part. I'm going to do a little bit here, and then I'm going to change this whole layout because websites. So saw a post recently, and part of it referenced a book called The Condition Monitoring Calculator by Abraham Brooks. Now, it was post was pretty good. It fit along with how I look at it, and I about halfway through, and then I scanned through the rest to do this. It's pretty easy scan because it's almost like slides. This is a self-published book. A publisher probably would not publish this. That is not that's not a negative at all. As a matter of fact, part of what I liked, I think what caught my eye was he had posted it and was talking about current signature analysis, which is on this page here. And like most people, as I think almost everybody in the industry, they'd heard so much misinformation about current and electrical signature analysis in the past that it limited what the capabilities are, and that's going to be another topic maybe next week. So we'll get into the details because there's a lot coming up related to electrical and current signature analysis, and I'll just throw this little bit in on it. It's basically vibration analysis using the motor as the transducer instead of an accelerometer. Almost everything is the same. There's some differences, and that's what we'll cover next week. On the 20th, I am going to be covering a demo of our new Empower Vibe, of an actual vibration analysis tool. I'm not doing tri-axis. I don't like tri-axis. I like single axis. It gives me better, more accurate information because the other two axes have to be implied because they're not in direct line with whatever. They're off at an angle. And to be accurate, you would have to know what that angle is, and then still it's a calculation versus a direct measurement. So we will get into that as well because I'm going to be covering that as part of the CBM thing. So some of the things in here, the basic premise is how to communicate between finance and the maintenance and reliability folks. And of course, I don't agree with everything in the book. I would be disappointed if I did. I mean, I try not to live in an echo chamber. We all do to some extent, right? So, I go through it. There's really no mention of energy. There is a couple of mentions of environmental things and, ESG stuff. But it's along the lines of what most people are told. A lot of the percentages are the stuff that's published everywhere. But what's really different about it is that it goes through and it provides a step-by-step approach, which the bullet point approach of basically slides I think it's slides being put into a book, basically. That concept works, and it works really well. So take it as you will, but I am not upset about buying this book at all. As a matter of fact, I've been reading it, and I'm taking my time reading it, and I'm going looking at references. I did finally look at the website today because there's a lot of, like I said, in-book purchases or in ebook purchases. So we'll take a look at that website shortly, and he's selling basically Excel spreadsheet calculators. Oh my God, not AI, which part of the reason why I liked it. It's a little bit better. I have not purchased or downloaded any of them yet. I may take a look at it to determine if they'll work for what we're doing. He does, as a matter of fact, get into in his towards the about half the book, he goes off of very specific things, like this one's industry applications, mining operations, and what's this one? Power plant applications, and sugar plant, and food and beverage, pulp and paper. So covers a lot of the major industries that makes it interesting. And then, of course, there's the section here on global implementation, like regulatory stuff, and so on and so on and so on. But he does get into the base calculations of the finances, and guess what? I really didn't see much in terms of what's called simple payback, and which is really really nice. He's got net present value, internal rate of return, those kind of things. The actual talk of finance. When you go into a CFO and you say, well, the simple payback is, sorry, it's not something that's really of value. So a lot of the stuff he goes into, he ties some of the things. I learned a few things, like how to tie some of the stuff that I really didn't pay attention to, because having been in the C-suite in a couple of companies over my career, I go, yeah, sorry, things like cost avoidance makes absolutely no sense. It has no value to me in the C-suite because it's not on the P&L. So one of the things you learn is when you get put into a leadership position and you're in the C-suite, you're tied to the P&L. So, you're outbound, you're looking out, and you're doing that tie. So I'm going to pause briefly and start up the rest of it, so I didn't have like you having to stare at this, and I could show the book. I do recommend it. Amazon has it. It's called Condition Monitoring ROI Calculator. The subtitle is The Complete Guide to Building Business Cases CFOs Approve, ROI Calculation Frameworks, Industry-Specific Applications, Executive Presentation Strategies. I saw a few in there. Basically a really great place to start. It's left a little loose, but I like that because, like, if Abraham went into I'm assuming he goes by Abraham. I know we know each other. I just I'm a name guy. Not a name guy, but anyways, his approach is different than what I would do, and I've been pretty successful at it. So in any case, let me go ahead. We're going to stop this. We're going to restart, and you're going to see some quick websites and some tools that you can either purchase, or the ones that I'm really going to show that I use. I'm going to do the online version because the last time I tried to do these off the computer, because of the recording thing, it really bogged everything down. So I'm going to go ahead and stop now, and we will restart. And we're back. So I'll be looking a little bit over to my right, your left, I think. In any case, because my screens are up on a second screen, all my controls sit in front of me on the interface. So in any case, welcome to the MotorDoc website. But let's go back here and take a look. So this is the website. This is associated with the book, and it is a variety of different calculators. I haven't gone to. Okay. So here's a snapshot. So all the calculations are back behind it and everything else. So yeah, it's kind of a salesy bit from the book, but they're Excel spreadsheets. Holy cow! I mean, these days, I'm so happy he didn't go, here's an AI. The nice thing about Excel, an Excel spreadsheet is the calculations are there. They're solidly there, even if they're not visible to the user. I don't know that, but even if they're not, they're there. It's repeatable. It's not going off and guessing at stuff. Okay, so there's different uses, but I forgot. But apparently, the medium I use has some AI built in. It doesn't like when I say anything negative about AI. It crashes my system for me. It's kind of funny that every time I do that, it crashes. So I had an error partway in. So we'll go back and we'll play with that afterwards. But in any case, I did take a look at it. A lot of interesting stuff. But as I was saying, what's nice is the repeatability. So I know that if I sit down and I put numbers in, and I crunch numbers, if I repeat that, I'm going to get the same results. Okay, so excellent book. Highly recommend it. I enjoyed it. I've been enjoying it, I should say. I can't use it to fall asleep to, unfortunately. So it's kept me up as I read it. Probably pick up a few good ideas out of it. I have a few concepts now, and I've got trying to think of how to incorporate them in some of the stuff that we do. If you're not learning constantly, you're not seeing other best practices, then why? So in any case, let's go ahead and we're going to talk about a different set of tools. Now, these tools are free. My approach, which is slightly different when I'm speaking to executives, is the ability to take and say, okay, I can tie these conditions, because I'm not looking at, well, I mean, you can even do it with an overall maintenance system, right? The worst case going from a reactive maintenance to any type of planned maintenance is at least a 14% reduction in energy costs. That can be tied directly to emissions, et cetera, et cetera, et cetera. So when I take a look at this stuff, I try to tie it to something like that, because it's a social. I've got two wins. One is I have energy ties to the P&L. I could show what happens if they decide to stop a program, because you start seeing the energy costs going back up again almost immediately. That's right, folks. You have a system in which you can implement, and it continues. I'm not a fan of standalone KPI like wrench time and stuff like that, even OEE. I mean, those are good when they're looked at in context. KPIs like that, when you select a KPI to emphasize on, like wrench time, you're going to sacrifice a bunch of other stuff if you put a hard line to it without understanding the operating context. And heaven forbid you're at, say, 40% utilization or 40% wrench time. Without the context, that gets in front of management. They're going to freak out and start laying people off. Well, why? Because most wrench time studies do not look at travel time, getting spare parts, all the other stuff that goes into that time where you actually have wrench on system. Studying up, reviewing the manuals, review all the stuff that you need to do your job well. So when I hear people go, "Oh no, we have a target wrench time of 95%," I'm going to be looking at a very, very broken program. So the idea is overall, you want to put them together. Uh, you want them to be part of a dashboard. If you want to put money to it, I use stuff like this. It's very measurable before and after. It's not something that gradually changes. So if you stop a program and go straight to reactive, the next major oops is going to have a direct energy impact that will be reflected on the bill. Okay, and that could be energy costs per unit of production or per person or per square foot. Usually recommend that you have either a certified energy manager, but definitely a certified measurement and verification professional involved in this. And those are recognized certifications out of the Association of Energy Engineers. Okay, so or somebody trained in the energy side, and they should be working closely with finance and any type of energy management programs you have in place. So you want to start bridging the silos. So the two programs we're going to look at real quick. We're going to start with we're going to cover Verify first, kind of in reverse. This is going to be the program where you show the improvements or changes, I should say, and then Measure is the one that I'm going to emphasize at the end. So let's take a look. We will at another time spend more time on these tools if there's interest, and you need to comment. If I don't see comments, I assume there's no interest. Okay, so just to get started, first off, up the notification went down. This is all downloadable. You can run it on your system. You can do backups and everything else. It works. All of this is solely on your browser, meaning that all the calculations, all the code is local, all the memory is local. You are not saving to DOE or any outside server. So the information you put in here is as secure as your browser is secure. Okay, so it's not being kept. It's not being kept by DOE. It's not being utilized. It's not becoming part of a machine learning thing, except for if your browser does that. Okay, so in any case, let's go ahead. This has the ability to start from scratch, upload a backlog, or let's see what happens here. I'm going to go ahead and load up the example. So it's adding all the stuff, and it's adding predictors. So what's kind of cool about this, okay, so it's going to put everything together here for us. And you can see it's created a company, it's created a bunch of information and dashboards related to the energy stuff. So a couple other things you can find out. Okay, so you can have it attached. As a matter of fact, I believe there's an API where you can actually attach your energy related bills to the software for doing the verification, so it will collect your work and everything else. The other important thing here is this weather data. So this will go and say, because, oh, by the way, Oak Ridge National Labs developed this. And get this, if you have interest, this stuff is also available on GitHub to be built into or as part of your own system if you want to bring it on board and modify it and do what you want to do. So in any case, let's go ahead and we're going to select Chicago, Illinois. I could also search by facility. Okay, so it's saying search for stations there, fetch stations, and then it's going to build down in all of the weather related data we need, because your energy consumption changes based upon a bunch of functions. Some of those are internal, some of them have to do with your production levels and whether or not you're sustaining those levels. And the other part has to do with things like weather, cooling and heating degree days, et cetera, et cetera, et cetera. So let's say we're going to use Chicago O'Hare. So everything is down in here. Ooh, neat. Yeah, so everything's down in here. Let's select O'Hare. Now I can change some stuff here. Let's take a look at 2025. Oh, I stopped it, so it's upset at me. So in any case, it'll go get that data. There we go. So here's the heating and cooling degree days, and I can drill down even further. This is 2025. You'll see heating based temperature, cooling based temperature. So whatever you select as a heating or cooling degree day, apparently it's having a little trouble, probably because of my memory usage. So let's go back to our base account, and we can take a look and see, the trend in MMBTU or whatever, right? So most will set up by MMBTU. Here's the savings based on prior usage. And then there's the everything else. So as I go in, I can start doing, so this is the different locations. Supposedly, let's go ahead and select one of those locations, et cetera, et cetera, et cetera. So you can set up stuff across the thing, and they're using both natural gas and electricity. So you can see they've got calculated energy use, actual energy use, right? And that's part of the tools that you need in order to evaluate any type of savings. So, all really good stuff. So let's take January to December. We can do it by groups or meters. We'll do it by groups, and then we'll just leave the default in there. And we're all set. So there's our time series. There's our squared variance. And here's more on like data correlation. So basically a regressive analysis. It looks like simple regression. So, these are pretty much really good tools, gives a good dashboard, provides the ability to do some real, analysis on conditions and everything else, and just on and on and on and on. So all of that's there. I won't spend a lot of time on it right now, just because you don't want to be here all day. So let's get into something that I meant to get the online tool. Okay, there we go. Let's go to measure. And when you go there, you can use this as standalone or whatever. And one of the okay, here we go. Measured data are stored in this browser on your local machine. Performing operations that delete browsing data for this website can result in data loss. Basically, your stuff is not backed up or stored somewhere else. Oh, this is new. So water assessment and water program, especially with all the data centers. So in any case, this is the latest and greatest. When you do it online, you can download it and do it on your computer and keep everything local. It's a standalone program, does not require you to be connected at all. There's a few things in here, such as treasure hunts and stuff like that, or going in and you can pick an area like, okay, maybe we want to do a survey. So So first off, there's all kinds of things that you can do, like an assessment. And that assessment, and by the way, the instructions are as you go through. We're going to get out of there for right now. You can do an assessment of a facility, put all your facility information in and everything else. So let's do just because I'm a motor dude, let's see, what do we want to do? Let's do a motor inventory example. So we do a plant setup, and then we go next. Okay, so this is all the default. Then we go next, and this is all the rest of it. And then we put in all of the information associated with motors and so on. This is a machine. You can see there's a bunch of them in there, and it'll tell you what it's calculating with. And then testing and quality, so energy consumption. Okay, so you have this. Then next, go in, and it will, break down the annual energy costs and so on and so on. So it'll give you an idea saying, hey, and of course, motor inventory, you can have a motor inventory in there and sort by certain motors and everything else. Okay, so when we get to analysis, it will start looking and helping you with repair versus replace decisions. It'll tell you the costs. It will even pull an estimated rewind cost. And there's a book out there that provides that information. Plus, DOE works a lot with ESA to kind of keep that. This can all be exported in any way you want. I mean, there's all kinds of cool stuff for doing it. Okay, so there we go. When we get into that, it's all there. Okay, so let's get back to here it is. Okay, so let's take a look at something else. Let's say we want to take a look at data exploration. Okay, we can sorry, we're not going to do that. But we can, let's load example data. Okay, and there we go. Next, here's example data for certain systems. And then as we continue, it provides us information. Okay, finish the setup, and then it's going to provide me information that I can use to kind of see where everything is. When I have, okay, and I can go by machine or whatever else, right? When I have some targets, I can go in, I could do something, say like a treasure hunt. So we'll go ahead and we'll do the treasure hunt example. I can go in and say, okay, so we are in dollars. We will use metric ton, which is 2,240, and the operating hours are 8760. Let's go ahead and take a look at our electricity costs and natural gas and any other things we want to add to it. Okay, other fuels, steam, compressed air, wastewater, and we can then go in and say, okay, with this, what happens if we make some change? So before actually implementing anything to show an improvement, you can, if you put the information in, and it doesn't take too long if the data is available. Good job for an intern, right? So get that stuff entered in, and then go ahead and say, okay, what if we came out here and let's select a random one. And we replace lighting. Everybody's got to replace lighting. So we come in and we say, okay, we have an example. So we'll generate an example. We have metal halide machines. We're going to go to high bay LED. Now, if you follow me, you know that LED puts out a lot of harmonic content. 6.2 cents, that's really not reasonable, but we'll leave it there because it is an example. So at 8760 hours per year, it gives me my kilowatt hours per year and total lighting in lumens. Okay, so how strong is the lighting? Now there's going to be certain rules with how bright you want things. Okay, so modification, you go to the new system, and you look at the difference, and you also put in what the impact is on a lumens. Lumens per lamp, 4,800 versus 23,000. Now this is where you need a certified energy manager, because we're trained on looking at different types of lighting and everything else, right? So I go in there and I'm just going to look at just 2 fixtures. That's this. That's this. This is not like a whole bunch of fixtures, right? So Lamp Life claims 20,000 hours. This one claims 50,000 hours. Watts per lamp. And so basically that's what it's really going for. So I come in here and I look at the same period of time. I look at the change in energy use. I look at the reduction in lighting, because maybe I need to add more lamps to get my lighting up. Okay, number of fixtures. I'm sorry, this is overall fixtures, not per fixture. That fixture number 1 is type of fixture. So I've got 452 fixtures. But in any case, electrical savings comes out to about $90,000 per year, but I lose lighting. So then I can go in and I can start playing with the different types of lighting systems to say, hey, where can I get, or maybe this was too bright and this is better, because there's also types of lighting. Okay, so there's different temperatures associated with lighting that can compensate for reduced lumens. It's all about doing that. So I can do this really quick, and then I can do all of my study and see what actually makes sense. Say a vendor comes in and says, hey, I'll replace all those, get your energy costs down. And sure, and you put it in, and all of a sudden everything's dim and gloomy, and then you've got unsafe situations, right? Those are things that you want to pay attention to. So you would be able to do that right in here. You put the stuff in. You would use the pull down menus, etc. Okay, so let's go ahead and take a look at another treasure hunt idea real quick, and then we'll start concluding this. That's an assessment. I don't want to do that. I want to do the examples. Compressed air example. It's going to be a little more complex. Well, let's take a look at it. Okay, here we go. If you need any help, click the user manual. User manual. There it is. So we'll do, I think there should be an example in here as well. Okay, so we're going to use that. We're going to use 10 cents per, unlock, 1. 10 cents, demand cost $5 per kilowatt per month. Any type of stuff here. So let's go ahead and we will just use whatever. So atmospheric pressure, total air storage. So it includes how to do the calculations. Okay, and then I'll bring it back. Control method. Yeah, we'll just leave it as default. yeah, the zip code is for that area, then that gives the total emissions rate. So you start in here, and then you can take a look and say, okay, here's what I have. What if I make any changes? And you start making those changes. Could be something as simple as, well, let's get through here. So let's say we're using the example from what we had already stored. And then we can start into different scenarios. Okay, so let's go ahead and reduce air leaks. Okay, and we want to target, let's say we reduce by 20%. And then we reduce inline efficiency. We do other things here, whatever we want. As soon as we do that, then that should update over here. Okay. Let's see, view, add all scenarios. Okay. Scenario 2. Okay, so when we do the scenarios, we come in here and it's going to give us 37% improvement. So all the savings and all the calculations, now these can of course be saved for whatever. So this is the system, and you can actually draw this out. And then you can use this to report out. This is a Sankey diagram, and then we can go to different calculators. So basically, you have the ability to go through and try different things. Some of it looks complicated, so you start with the easy stuff, like a simple motor, simple pump, whatever. And by the way, as I click on these, that's a one-off, meaning if I come down here to the motor, I come in and create a new motor thing, add a whatever, and I can then do all the setup and everything that I wanted to before. So this in the end will give me the calculations I need, right? So let's go ahead and we'll do a simple motor calculator. So here's the calculator. So we're going to go in and let's do repair versus replace. 8760 hours. We have 150 horsepower. That's 75% loaded. We're going to increase our energy costs because there's no way that makes any sense. The efficiency of the original motor is 92%. The new motor is 96%. The replacement purchase cost, $13,000. Rewind efficiency loss is assumed to be 1% per rewind. Okay, so pushback. Great, give me all the pushback you want. Here's what I know. I didn't get an opportunity to vote on IEEE 1068, the motor repair standard again. And my goal was to keep the core losses as low as possible in there so that it cover the error, but you didn't have increased core losses per rewind. Well, the pushback is they wanted to allow a 20% increase in core losses per repair. On an average motor, that equates to 1%. I've done articles on this already. I know some people aren't going to like that. I know there's studies thrown around. I know the history of all of it. So I would use the 1% per rewind reduction. Yes, you can get a zero reduction per rewind. Now, also, I will note that because the repair shop has not performed an IEEE 112 Method B before, an efficiency in the field study, especially if they're not using like our test equipment, the empath or similar, which calculates field efficiency, okay, built in, you can't hold them to a specific efficiency level because you don't know what it was. And heaven forbid if it's been rewound before by a schlock shop. And unfortunately, I've seen some companies that I used to think were excellent that I don't term as excellent anymore. So be aware. So you keep that in there for your calculation. A good repair spec. Like if somebody actually follows the 1068 or the ANSI ISA AR100, which is no cost, right, to end user. An ISA shop or an ISA person can provide you one. I believe that hasn't changed. If you make sure the shop's following that and you're paying attention to how they're repairing your equipment, that shouldn't be an issue. That 1% pays for, or higher, by the way, pays for having somebody knowledgeable paying attention to the thing. So in any case, so we go in there, we've adjusted that. We're saying 10 cents per kilowatt hour. The efficiency of 92 versus 96, purchase cost $13K versus a rewind at a 1% and a cost of the rewind, say $8,000. Okay, just their example. So, Okay, so when I come out of there, then I should be seeing this. So an existing motor costs this much. Rewound motor is going to increase the operating cost, so about $1,000. New motor is going to reduce the operating costs. The annual savings, the increase, so negative means the cost goes up by $8,700 per year, and kilowatt hours per year, and down by this amount. So cost savings meaning it's not a savings, it's an increase of 878 versus 3,300. Simple payback is this. Okay. Replace versus rewind, incremental savings. So this would be, your simple payback thing there. So if you go to the repair versus replace, that's the calculation you want. That means that your simple payback means that if you go ahead and do the new motor versus rewind, it'll pay for itself in 1 year. You'll see a reduction in cost. So this is part of that decision making. Now, when I do all of that, then I can go to the US EPA calculator. See if it shows it. Or better yet, I could, okay, yeah. Let's see if they show it. There we go, greenhouse gas equivalencies calculator, because this really isn't built in there. It's built in to verify. It's not built into the other. And we say, okay, we avoided, so we reduced. Okay, so if we select kilowatt hours used, that's going to use a different calculation. So there's two methods of approaching reduction. Or one is an inventory of your greenhouse gas emissions, or CO2. The other one is reduction. A lot of companies still look at this. So it's a tool to help support, especially if your mission and vision calls for environmentally whatever, Okay. You notice down here, if you've got a website, this is the widget. Put it on your website. I do. I've got it on the MotorDoc AI website. If you're watching this off of the MotorDoc AI website, just go down to the bottom. It's right there on the right-hand side. So in any case, so let's see. We had a reduction of 42,078 kilowatts. So 42,708, if I got that right. I might have backed. So we're going to go off of the local zip code, and then we're going to convert our data. So what that's going to say is, okay, this greenhouse gas emissions from going to a new motor versus rewinding the old motor, we're going to do this in metric tons. It reduces it by 37.6 metric tons per year. and then it'll give you an equivalency. Now, this used to be a lot prettier. I think some of it is driven in certain instances, but it says, okay, it's equivalent of removing 8.8 gasoline-powered passenger-driven vehicles for 1 year, that kind of thing. Or the equivalent of $100,000 miles driven by a vehicle, or 13.3 tons of waste recycled, or trash bags or whatever. So you have this chart here, which is friendly and able to be shared, and that gives you information that you can show on top of the energy savings in order to do something. And you saw how quick this was, just doing a quick repair versus replace. Okay. The other kind of cool things in here, motor performance stuff or full load current. Let's say it's 60 hertz motor, 100 horsepower, 1780 RPM, energy efficient, and operating at 460 volts. Okay. The full load amps is estimated to be around 114 amps. This is pretty accurate. This is off of a massive database they've had, so they built all of this stuff in there. So all these other calculators, you've got general calculators, unit conversions, power factor stuff, et cetera, et cetera, et cetera. You can go in and do different things like, let's see what's claimed here. So real power is KW. Minimum required power factor, we'll say, is a 0.9. Okay, so 9.2. Let's say that's from a specific area. Power factor adjusted or actual demand. Marginal cost of demand. Demand cost would be 5. We'll just use their 5. I could generate an example. Let's go ahead and generate their example. There we go. So that I don't waste your time by doing this. So they're at 0.8. So they go in here, and what they do is they are looking at power factor penalty costs. Okay, so this is power factor penalty costs, not direct kilowatt reduction. Okay, so annual power penalty is this. Proposed fixed capacitance is that. Proposed variable capacitance, then capital cost to put in that correction being 12K. That'll give you a 1.5 year simple payback. Then I would use verify for the more complex payback methods. Let's see. Yeah. Okay, so that's just a quick overview. If you have any questions on it, well, actually, we'll do. I've done workshops on this before. I'm going to cover it a little more in depth in one of these episodes, et cetera, et cetera. So, excellent tool for providing you some ways and means to make decisions beforehand, evaluate, provide the impact in actual energy, and it doesn't have to be electricity. I focused on electricity, but oil, gas, whatever, and then being able to tie that to your maintenance activity. Because what we learned in the 1990s, when I was part of all these challenge programs, okay, the original Motor Master, which is built into this and everything else, I'm one of the people who was involved in all of that stuff, advising on the software, but actually helping write on the manuals. All of that stuff. In the end, we went, wait a minute, why are we focused on new? The work associated with repair and maintenance is going to have a bigger impact. In any case, thank you very much, folks, for listening in, and hopefully this was useful. Broad topic. I know I went pretty long, so get what you can out of it. We will take clips and make them available. And if you're watching this on YouTube, make sure to like and subscribe. Lots more coming.